Hi everyone, I am Dr. Chintan Singh from DCA, Department of Computer Application from Chandigarh Group of Colleges. Today I am going to discuss K maps, why we use K maps and what is the benefit of K maps. Today I am going to discuss with you. What is the role of K map? A formal definition of K map. According to the formal definition, Karnaugh maps provide a systematic method to obtain a simplified sum of product Boolean expressions. Why we use K map? The use of K map is to solve the logical expressions. Means in case of digital circuit, when we want to reduce the hardware components, then we have to simplify the logical expression. The method to simplify the logical expression is used as a K map. This is the role of K map why we use K map. The full form of K map is Karnaugh map. Another definition of K map is this is the compact way of the representing a truth table and the technique that is used to simplify the logical expression. The second thing why we use K map, the K map is used to simplify the Boolean expression, and the second thing is it is the way to represent the compact way of the truth table. What is a truth table? Truth table is a table which is used to represent the input-output combination in case of a logic circuit. This is the compact way of representing the truth table. This is why we use the K map. Now, in case of K map, how many variables in the equation should be when we use the K map? If there are 4 or less variables, the K map is the best way to solve the Boolean expression. As the variable number are increased, it is difficult to handle it with the help of a K map. Now, what is a K map? K map consists of a grid of squares and each square representing one canonical combination of variables. Now, what is a K map? K map is a grid of squares. Grid of square means, for example, it is a grid of squares like this. Now, in this grid, I have used 4 squares. K map is a grid of squares and each square is used to represent one canonical main term. Canonical main term. Now, what is the meaning of canonical terms? In case of Boolean expression, canonical terms means if there are 3 variables in the equation, then in each element of the equation there should be 3 variables. If the equation is not in the canonical form, then we have to change that equation into the canonical form. For example, I write the equation f is equal to x complement plus xy. Now this equation contains 2 variables x and y. Now in this equation, each element, there are 2 elements x complement y and xy. Each element contains the 2 variables in the form of complement or the variable as. Now this equation is in canonical form. Now this is the first requirement of the K map. When we are going to solve the Boolean expressions using K map, the equations should be in canonical form. Now the next thing is which differ min terms are used. Min terms which differ only by one variable to the adjacent both vertically and horizontally. Now in each box, in each square grid, we use a min term. What is min term? If the equation is represented in SOP form. Now there are 2 ways to represent the Boolean expressions. One is SOP and the second one is POS, sum of product and product of sum. Now in case of when we represent the equation in SOP form, each element of the equation is known as min term. Now each square grid in the K map is used to represent the min term. And each square grid of the K map is differed by one variable from the adjacent box. Means if the adjacent box contains the 0 value, then next box contains the 1 value. Means there is a difference of 1 variable. Each square represents either a min term or max term. A K map of n variables we have 2 raised to the power n square. Means in K map we use min terms or max term. Where we use min terms and where we use max terms. Main terms are used in case of SOP. When we are going to solve SOP equation, the sum of product equation, then we use the term main term. When we use EOS equation to solve, then we use the term max term. Then each square grid in a K map is used to represent a main term in case of SOP and max term in case of POS. For a Boolean expression, product terms are denoted by 1 while the sum terms are denoted by 0. For example, we are going to solve a SOP equation with the help of a K map. Now we have to represent each and every element of the SOP equation in the form of a K map, in the form of a table or a square grid. Now each term in case of SOP, we have to put a 1 value in the corresponding square grid of the K map in case of SOP equations. In case of POS, we use geo to denote the max terms. This is a denotation of the main terms or max terms in the K map. Now, how we simplify the equation with the help of a K map? Means minimization techniques which are used in a K map. Based on the unifying theorem, x plus x complement is equal to y. When we put the values into the K map, then we have to simplify the equation. Now, what is the basic idea? How we simplify the equation? That depends on the unifying theorem. Unifying theorem means variable plus complement of the variable is equal to 1. By using the uniform theorem, we are going to eliminate the variables from the equation. The expression to be minimized should generally be sum of product form. If necessary, then we have to perform the conversion process. Then we can implement US equation into the K map, but generally we use K map for SOP, means sum of product form, for simplicity. If the equation is already in sum of product form, then we can directly implement it into the K map. If it is not in the SOP form, then we have to change it into the SOP form, then we implement it into the K map. The function is mapped onto the K map by marking 1 in those pairs corresponding to the terms in the expression to be simplified. Now, first of all, we draw a K map, then we have to fill that K map. How we fill that K map? The K map is filled according to the values or the elements that are given in the expression. Now, according to the elements or the values that are given into the expression, we put 1 into the corresponding square grid. 1. We mark 1 into the corresponding square grid. Pair of ones of the map which are adjacent are combined using the theorem x plus x complement is equal to 1, where y is any Boolean expression. Now, next thing, after putting the 1 or the corresponding elements into the K map, next thing is the group. Now, we have to create a group. How we create a group? We create a group by keeping in the mind that we have to implement the unifying theorem. Unifying theorem is implemented to eliminate some variable from the expression to simplify that expression. The minimization procedure consists of recognizing those pairs and multiple pairs. After perform the grouping part, then we have to identify the groups that we have formed in the K map. These are the circles indicated reduced term. That group represents the reduced term, means the terms after simplification. The group which can be circled are those which have 2 ones, 4 ones, 8 ones. How we create groups onto the K map means 2 adjacent one can create a single group. Similarly, 4 1 the adjacent 4 ones can create another group. Similarly, we can create a group of 8 ones. This is the way how we can create a group in K maps. Note that because of squares on one edge of the map are considered adjacent to those of those squares. Now, for example, we are going to represent a K map in the form of a square grid. For example, this paper is used to represent a K map. Now, the adjacent means the corner of this paper. For example, one square grid at this corner and the other square grid on this corner. If I fold this paper into cylindrical form like this, I fold this paper in cylindrical form. Now these two boxes form a single group. Now these two corners become adjacent to each other. Now they can form a single group. Similarly, the corners at the lower side can form a single group. Similarly, I can fold this paper horizontally. Then the upper and bottom corners can form a single group. When all the possible groups have been formed, the corresponding terms are identical. After forming the groups, now we have to apply the uniform theorem to eliminate the variables. Now, how can we implement? A group of two ones eliminate one variable from the original thing. When we create a single group in which two ones are used, it will eliminate one variable. Similarly, the group of four ones eliminate two variables, and the group of 8 ones eliminate 3 variables. What is the use of elimination of the variables? By eliminating the variable, we got a simplified equation. Simplified equation means we can implement to that circuit with a lesser number of hardware components. Now, I am going to explain the K map with the help of example in which we are using the two variables. In any K map, each sphere grid represents a main term. For example, now I am going to explain the K map for two variables. Now, in case of two variables, how many sphere grids are required to represent a K map that are generated with the help of formula 2 raised to the power n, where n is the number of variables in the equation. Now, in case of two variables, number of variables are 2, so 2 raised to the power 2, we need a grid of 4 spheres. Now, grid of 4 spheres is required to solve a Boolean expression which contains two variables. Now, this is a K map for two variables. Now, how we represent the variables? There is a way how we represent the variable. One variable is represented vertically and one variable represented horizontally. For example, there are two variables in the form of x and y. X represented the vertical values and y represented the horizontal value. Now, how many possible values of x? X can be 0 or x can be y. Similarly, the two possible values for y is 0 and y. Now, we have to represent the main terms into the K map. Now, the first, this sphere grid represents 0, 0 value, means 0 value for x and 0 value for y. Similarly, this sphere grid represents 0, 1. 0, 1 means the first value represented for x and the second one is for y. And this is for 1, 0 and this is 1. If we write in terms of main terms, means this is our M0 first main term, this is M1, M2 and M3. This is how we represent a K map for two variable equations. A equation which have a two variable can be implemented by using this type of K map. K map can be minimized with the help of grouping of the terms from a single term. Now, after putting the values into the K map according to the equation, next thing is grouping. When forming the groups of the sphere, observe or consider the following point. When we are going to create the groups, we have to keep some point in the mind. Those points are, first one is every sphere containing must be considered at least one. Every sphere which contains 1, means which is filled with 1, should be considered into the grouping. At least 1 time. A sphere containing 1 can be included in as many as groups as desired. Means there is overlapping of the groups. Means one single one or one value can participate more than one groups. Means groups can overlap. A group must as large as possible. We should Keep in mind that the group should be as large as possible. What would be the benefit of this thing? We can minimize the Boolean expression in better way if we keep this point in mind that the group should be as large as possible. These are the some possible groups, means the adjacent blocks like these two square grid can form a group with these two square grid. A group of 4 ones. Similarly, a group of 2 ones. This box represents a group of 4 ones. And similarly, this group also represents a group of 4 ones. These are the possible groups in case of a K-map. If the square containing 1 cannot be placed in a group, then leave out to include the final expression. If there is a one value that cannot participate in any group, then that value can be included directly into the answer part. Means there may be some one that is not included into any group that should be included into the answer directly. The number of squares in a group must be equal to 2 raised to the power. How many square grids are provided into the K map that are accessed with the help of a formula 2 raised to the power n, where n is the number of variables in that particular equation. For example, if 3 variables are there in the equation, the square grids that are available into the K map is 2 raised to the power 3, that is equal to 8. The map is considered to be folded cylindrical. I already explained you the map is in cylindrical shape, means the corner can participate into a single group. The simplified logical expression obtained from a K map is not always clear. This is an important point. The result of the K map is not always unique. Means everyone can make a grouping in different way, so result can differ from person to person. Means there is not a single answer for a when we use K map to simplify the application. Before drawing the K map, the logical expression must be in canonical form. When we are going to implement the equation with the help of a K map, first of all the equation should be in canonical form. What is canonical form? I already explained you. If the equation is not in canonical form, then we have to change that equation into the canonical form. These are the examples how we put the values into the K map, then how we perform the grouping into the K map. Now in this example, we show the overlapping of the group. Means this is a group of 4. Then again a blue color group is group of 4. Groups can overlap. This is a folded part of the K map. Means this one can participate in a group with this one. Similarly, these two ones can form a group of 4 ones by including these 2 ones. This is again a group of 4. Similarly, corners can participate in a single group of 4 ones. These are the some invalid groups. Means the groups cannot be formed in that form. These are the invalid groups. Now we are going to solve an example. First of all, I am going to start with the 2 variable equation. Now the equation is given. The equation which is given f is equal to x complement y plus xy. Now first thing we have to check how many variables are involved in this equation. There are 2 variables are involved, so 2 raised to the power 2, that is 4. 4 square grid K map is required to solve this equation. Second thing, we have to check whether this equation is in canonical form. Yes, this equation is in canonical form. How we can check? Because this equation contains 2 variables and each and every term contains those 2 variables, either the variable itself or in the form of a complement. Now we have to draw a K map. How many square grids are required? 4 square grids are required. So I draw 4 square. Now we have to represent the variables. You can interchange the variable. X, the possible values of x are 0 and 1. Possible values of y are 0 and 1. Now the first square grid represents m0 M1, M2 and M2. What is M1, M2? These are the main terms. Main terms are represented by lowercase means small m, and the max terms are represented by capital in case of POS. Now the equation is given to us x complement 1. Now I can write in the form of bit. This box represents 0, 0, 0. This represents 0, 1, 1, 0 and 1. If I change this equation in the form of 0 and 1, then I write 0 in case of the complement. Now x complement means 0 value, y means 1, then 1 and 1. If the variable is represented by using complement, then we have to write the 0 corresponding to that variable. If the variable written as it, then we have to write 1. Now we have to put this equation into the K map. Now according to the K map condition, we have to write 1 corresponding to the main terms that are given into the expression. Now which main terms are given in the equation? This is M1 and M2. These two main terms are given in the equation. Now these two main terms, according to these two main terms, we have to fill the K map. Now how we can fill the K map? Now corresponding to the first main term means M1 or 0. 01 means this box. Now we have to put 1 in this box. Similarly, next value is 1, 1 or M3. M3 is represented in this box, so we have to put 1 in this box. The other boxes can be left blank or we can fill 0 in that. Now we have to filter K map. Now the next part is the grouping part. How we can make a group? Now there are only two values. Only one group is possible. This group of. This is the next step. How we can create a group in case of K map. Now we have to write the result of this equation by using simplifying theorem. Now corresponding to this group, we have to check which variable change its value. Now corresponding to this group, the x value, corresponding to this one, x has 0 value, corresponding to this one, x has 1 value. Means x value changed during this group. So x will be eliminated. But the y value means same for this one and this one. So y value same, it will be act as an answer after simplification. So this is the result of the K map after simplification. Now we have taken the example of only two variable equation. Now in case of three variable equation, now how we use K map in case of three variables? First thing is, now we have three variables. How many square brackets are required? 2 raised to the power 3 means 8 square brackets are required. Now 8 square brackets are required, so we have to draw a K map of 8 square brackets. Means 2 rows and 4 columns. Means one variable is used represented vertically, and the two variables, for example y and z, represented horizontally. In this example, we are taking three variables in form of x, y, and z. Now the possible values of x are 0 and 1. Now in case of two variables, how we write the values? The possible values are 0, 0, 1. Then after that 1, 0 and 1. Now in this case, there is a condition in the K map that the adjacent box should differ from one variable. Now in this case, 1, 1, 1 and 1, 0. Now how we write this in case of, let me write it 0, 1, 1, 1 and 1, 0. If I write 1 0 and 1 1, now in this case, compare these two values. This variable from change from 0 to 1 and this variable again came from 1 to 0. Means there is change of two variables, but according to the condition of the email, the change should be only of single variable. So we rewrite the condition 0 1 and then 1 1. After 1 1 we write 1 0. Now these two values differ by only one variable. Now how we represent the main terms? Now if we write the values x value first and y z value. 0 then 0 0 1 0 1 1 0 1 0 then 1 0 0 1 0 1 1 1 1 this is 1 1 then 1 1 0. If I write in terms of main terms, this is m0, m1, decimal equivalent of this is 3. So m3, m2, m4, m5, m7, and m6. This is the example of the K-map in case of three variables. This is the way how we represent the main terms in case of three variables. I am going directly jump to the example. Now this example is given to us. In this case, three variables are given to us. We have to fill the K-map according to the three variables. Then we have to solve this equation and simplify it. The result is equal to. Now, which equation is given to us? F is equal to x, y, z, z complement, then x, y, z, x complement, y, z. Now three variables are there. So first of all, I have to draw a map which contains 8 square waves. X, y, and z. 0, 1, 0, 0, 0, 1, 1, 1, and 1, 0. So this works to represent 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, then 1, 1, 0. And now, according to this equation, this first element represents 1, 1, 0. Then this second element represents 1, 1, 0, 1, 1. Now we have to map this equation onto the K map. Now 1, 1, 0, 1, 1, 0, 1, 1, 0 means we have to put 1 in this square bracket. Then 1, now we have to put 1 in this box. 0, 1, 1 means we put 1 in this box. So we fill that K map accordingly. After filling the K map, we have to create the groups. Now, how many groups are possible? For example, I have created a group of 2 ones. So we have to cover maximum ones into a minimum groups. So this one can be included with this one in a single group. So the groups can overlap. This is a second group. Means we have created 2 groups of 2 ones. Now after grouping, next thing is we have to write the result. Now according to this group, we have to check which variable is changed during this group. X value changed from 0 to 1. So X variable will be eliminated. Now corresponding to this group, vertical group, the Y value is 1, 1. So the result is YZ. Then we consider, then we put a plus sign in case of SOP. In case of USC, we use dot sign. Then according to this horizontal group, we have to check which variable is changed. Now corresponding to these 2 ones, X value means 1. So X should be in the answer. Now corresponding to these 2 ones, we have to check the upper 2 values. Y value means 1 over here and 1 over here. So y should be included into the answer. But the z value changes from 1 to z value changes from 1 to 0. So z will be eliminated. So the final answer is yz plus xy after the simplification of equation of three variables. Now next is how we are going to solve a K map of four variables. Now in case of four variables, first of all we should know how many square grids are required. That means if there are four variables, 2 raised to the power 4. 2 raised to the power 4 means 16 square grids are required. Now 16 square grids means 4 rows and 4 columns. These two variables are represented for example, variables are represented as w, x, y, and z. So w and x are used to represent the variables vertically and y, z represent the horizontally. So the possible values are 0, 0, 0, 1, then 1, 0. In place of 1, 0, there should be 1, 1. Then after 1, 1. 1, 0. Similarly, 0, 0, 0, 1, 1, 1, and 1, 0. Now we have to fill it with the main terms. Now this is our M0, M1, M3, M2. Then M4, M5, M7, and M6. Then, because these two values are interchanged, so next one is M8, M9, M11, and M12, M13, M15, and M20. This is how we are going to fill the K map with the help of four variables. Now, as I already explained, we can fold the K map so that the adjacent or the corners can be converted into a single group. This is the equation which we are going to solve with the help of a K map. Now, equation can be given in terms of min terms. Now, the first one means first min term, fifth means the fifth min term, 12th means 12th min term. Now, how we fill the K map according to the equation? We use four variables, means total 16 square grids are there. We have to fill the K map according to these values. We put 1 into the M1 position, then we put 1 at the M5 position, then we put M1 or 1 into the M12 position and 30. Means 4 ones are filled into the K map. Then next part is the grouping. Two groups are possible. One is vertical group and the second one is horizontal group of these two ones. Then we have to write the answer according to these two groups. For example, for this vertical group, we have to check which variable is used. Now, corresponding to these two ones, Wx for W value 0 to 0 means W value remains same, so W should be in the answer, but X value changes from 0 to 1, X will be eliminated. And for according to this group, the upper value is 0, 1 means Y complement Z. So the answer is W complement, Y complement, and Z complement. This is the result of the first group. And similarly, we can write the result of the second group. According to second group, this 1 represents Ws. So Wx, there is a mistake, Wx should be in the answer, and according to The upper values, which value remains same, y value means y complement is here in the answer. Similarly, another example with the help of four variables. First of all, we have to check the midterms. Then, according to the midterms, we have to fill the K map. After filling the K map, we have to create the groups. After creating the groups, we have to apply a unifying theorem to eliminate the variables. After elimination of the variables, we get a simplified Boolean expression. And this good simplified Boolean expression can be used to represent a logic circuit with minimum number of hardware. This is all about for the K map from my side. There is some more condition which we use dot definition. We will discuss in another lecture. Thank you very much.